Greetings, everyone. This is Mr. Dupes coming at you from the MAM Science Satellite Studios, and today we will be talking about how we plot earthquakes on a world map. And one of the patterns that we should see is that these earthquakes occur along plate boundaries. Now, behind me, you do have a world map here, and you can see in red here where one plate boundary ends and another one starts. Okay, so the big plate that you see right here is the Pacific Plate. And the Pacific Plate is an oceanic plate. In other words, there's nothing but ocean water above it. The Nazca Plate we talked about here, all right, is moving east, and it's subducting underneath the less dense continental plate, which is the South American Plate. And we talked about a few weeks ago that when an oceanic plate subducts under a continental plate, that is going to cause volcanism. All right, so volcanic mountains will form, and that's what the Andes Mountains here are. All right, they're volcanic. And the plate boundary continues up the west coast of the United States, all around here, all right, along the eastern part of Asia right there. We're going to talk about Japan and why Japan is known for not just earthquakes, but very powerful earthquakes. Continuing along the Marianas Trench right here, New Guinea. New Guinea is very active when it comes to volcanoes. Yesterday there was a video I showed you on Christchurch, New Zealand that occurred in February of 2011. But all along you see here are plate boundaries. And we're going to see when we plot these earthquakes if they are consistent where these plate boundaries interact with one another. One of the sites that I want to take you to, and you can just type this into the search. It is earthquake.usgs.gov. USGS stands for United States Geological Survey, and these people are probably the front runners as far as accuracy on where these earthquakes occur. So I'm going to show you what it looks like right here once you get to the site. And off to the left, it shows you very good information about each earthquake that occurred throughout the day. It shows you the magnitude of the earthquake, the epicenter, the focus of the earthquake. If you recall, the focus of the earthquake is the point inside of the earth where the earthquake energy is released. It shows you the date and time that it occurred as well. So once you go to this site right here, one of the cool things that I want to show you, in the upper right-hand corner, it says Zoom to. And it gives you different options to zoom to. Alaska is very populated with earthquakes pretty much on a daily basis as well. California, central United States, Hawaii, Puerto Rico, and throughout the world. Okay? So what I'm going to do is I'm going to take you to California right here. And one of the things that you'll notice about California is that red line right there, that is the San Andreas Fault. Now, a lot of kids don't know this, but the San Andreas Fault separates the Pacific Plate off to the west here and the North American Plate, which is off to the east. So these coastal cities like San Francisco, Santa Cruz, San Jose, Los Angeles, San Diego, even though they're in California, they're on the Pacific Plate. So they're not on the North American Plate. The San Andreas Fault is a strike-slip fault, all right, and they move by shear forces. And California is very active every day in earthquake activity as well. So that's something I just wanted to show you, one of the features of this website right here. You can explore a lot of very good information on it. Okay, so the plate boundaries, one of them I really want to point out to is the island of Japan right here. And the reason I want to show you that, and the reason Japan is very active when it comes to earthquakes, is that there are 4 plate boundaries that meet there. Okay, so believe it or not, this part of eastern Russia is part of the North American Plate right here. Okay, so the North American plate just doesn't end in Alaska. It actually continues on to this part of eastern Russia. And it actually heads down right where Japan is. Okay, so that's one plate boundary. The Eurasian plate right here touches along Japan. Just south of Japan is the Philippine plate. Okay, so that's 3 plate boundaries, and the Pacific plate. So that's 4 plate boundaries that meet on one island. So when Japan experiences these earthquakes, a 4.5 earthquake, a 5.0 earthquake, which would be significant in the United States, is pretty much daily routine for the people of Japan. You probably want to know where the largest earthquake ever occurred. And it actually took place on May 22nd, 1960 in Valdivia, Chile. So once again, this is along a plate boundary, the South American plate meeting the Nazca Oceanic plate. And it produced a 9.5 earthquake, which is the largest earthquake ever recorded in the world. Now, were there other earthquakes 9.5 or possibly greater? In my estimation, the Earth is 6 billion years old. I would say yeah. All right, but it doesn't occur often. All right, but I'm pretty sure there were a few earthquakes that were more than the 9.5. Okay, so going back to Japan right here, I'm going to give you some stats about the Great Japan earthquake that occurred on March 11th, 2011. It was a 9.1 earthquake, and it was the largest earthquake recorded in Japan's history. And the focus or the depth of this earthquake was 29 kilometers deep, which is about 18 miles. That is extremely shallow for a major earthquake like that. Okay, so there was mass damage done. In fact, there was $360 billion worth of damages. Now, after major earthquakes occur like this, there tends to be aftershocks. In other words, significant earthquakes that occur as a result from the very first earthquake. Now, when you talk about aftershocks, they might last up to a week, up to 2 weeks worth of earthquakes, and that's after a major earthquake. Well, after the Great Japan earthquake in March of 2011, there were almost actually 14,000 aftershocks. And the last aftershock that occurred, that was recorded, was on March 6th, 2018. So that is 7 years worth of aftershocks. So it gives you an idea of how significant and how potent these earthquakes are. So what we're going to do now is we're going to plot our earthquakes, and we are going to use the website, the United States Geological Survey, earthquakes. So what we're going to do is we are going to take our marker right here, and we're going to plot about 5 earthquakes. And then we're going to leave it on throughout the course of the week, so hopefully we get an idea or a pattern of where these earthquakes are occurring. So I'm going to go to the world view right here. And in New Guinea, right here, New Guinea is right there, okay, just north of Australia. There was a major earthquake that occurred there, which was a 6.1 earthquake. Okay, and the depth of that was 466 kilometers, the focus of the earthquake. Now, that's very deep, okay? But a 6.1 earthquake is a 6.1 earthquake, all right? So that's pretty significant. So we're going to plot one right here, okay? And then we're going to go to South America. And South America right there. And the information, once you touch these circles, this was a 5.3 earthquake, and the focus of the earthquake was 46 kilometers. Okay, so we are going to draw it right there. Once again, that is where the Nazca plate meets the South American plate. Might as well touch up on the United States right here. And that was a 2.6 earthquake. So that's not very significant. People in that area probably heard a loud rumble sound. They maybe felt a little bit of movement, not very much. All right, but we're going to record that anyway because it backs up the fact that earthquakes occur along plate boundaries. Okay, so there's our third one. And just right here, just south of Japan, where the Pacific plate meets the Philippine plate, we're going to record that there. And we're going to go with one more. Okay. And there were a series of small earthquakes that occurred in Puerto Rico. A bunch right there. And Puerto Rico, along with the Greater Antilles and the Lesser Antilles, they sit on a plate boundary where the Caribbean plate meets the North American plate. So we're going to plot earthquakes there as well. Okay? So these plots right here, all right, we're going to keep them up for about a week and a half. We're going to add earthquakes every day to see if the epicenters are consistent with the plate boundaries. That is all for today. This is Mr. Dupes coming at you from the Ma'am Science Satellite Studios saying, so long, Raider Nation, I am out.